Okay, so I will get started with today's session. Some more people are joining, but if you are able to see that someone wants to join the call, then please admit them. I'm not sure if you can see the request or not. Okay, I hope my screen is visible to everyone. Okay, great. Is my voice clear? Is it fine? Okay, thank you. Okay, so I will get started now. So hello and welcome to the problem solving session for NPTEL course Getting Started with Competitive Programming, and this course is offered by Professor Neeldhara Mishra, and I am one of the TAs for this course. I am Nikita Yadav. I am a PhD student in the Department of CSA, IISc Bangalore. I see there is a request. And I will be taking a live class every week on Friday 6 p.m. to 7 p.m. starting today, and as you all have joined the Google Meet link which is provided to you, and the recording will be done for these lectures and it will be provided to you also. So today's agenda is to solve two problems. So these were the problems that were given as programming assignment in the past offering of this course, and the week ones for week one we are actually doing AdHoc and Implementation, very simple basic problems. So yeah, so let's get started with it. Okay, so you all must have seen your programming assignment as well for this offering, and these questions I have taken from the previous offering of this course. So similarly in the previous offering also there were two programming assignments. So today what I'm going to do is that first I will read the problem statement, and then we will all discuss that what can be the solutions, and you all are welcome to tell your approaches. Then we will discuss each of them, and then we will also implement one of the approaches. So let's get started. So the first problem is incrementer. It says that you have a collection of n balls. Each one has an integer written on it. You also have a magic bag called the incrementer. When you put a ball inside the incrementer and pull it out, the integer written on it increases by 1. The magic bag is big enough to hold any number of balls at once. However, it costs 1 rupee to use it once. I'm not sure if I can. Let me see if I can change the settings. It's the details. Okay, I don't know, I will check this later. For now, let's okay. So you want all of your balls to have the same number of them. Your task is to figure out what is the minimum cost of making this happen using the magic bag. So the problem is saying that you are given n balls and there is a number written on every ball, and then you also have a magic bag in which if you put any ball and when you pull it out, then the number on the ball will be incremented by 1. So let's say you put a ball in it with number 1, and when you take out the ball, the number on the ball will be changed to 2. Okay. So then you want to find the minimum number of times that you will have to use the bag. That is the minimum cost. So let us see the example to understand the problem a bit better. That is, let's say this is the input. It is saying that there are 6 balls. 6 here represents that there are 6 balls, and these are the numbers which are written on the ball, and every ball has the same number, which is 4. So what is the minimum cost to make the numbers on the balls equivalent, like same? So here we don't need to do anything because all the numbers are same right now. And for the second test case, which is 4 balls and 3 of the balls have number 1000 and one has 1001. So what we need to do here is that we can put all the first 3 balls in the bag, and then we can take out all the 3 balls from the bag, and that way we will have all the balls with the number on them 1001. Okay, I hope that the problem statement is clear. So let me now just read out what is the input format and what is the output format. So in the input format, you will be first given an integer t, which is the number of test cases, and the maximum number of test cases can be 10,000. So this is the constraint on the number of test cases. Then for every test case, you will be given the number of balls in your collection, which is limited by number 50. So maximum can be 50, and then the number on each ball can be an integer which is less than equal to 10 to the power 9. Okay. So do you have any question, any doubts in the problem statement? Okay. Okay, so then for each test case, okay, so if there are no doubts, can we discuss the solution for the problem? So how will you solve this problem? You can take a look at the example here again. Any ideas? Yeah, that is right. So Vinayak, would you like to unmute yourself and tell?
Yes, ma'am.
Yes.
So, ma'am, all we have to do is we have to find if we are taking the number of elements in the vector, and we have to take the input, and the maximum number of the maximum value will be the value that we have to reach after putting it in the bag and taking the ball out. And we will have to do it as many times as there is a difference between the largest and the smallest element to make the equal.
Yeah. Yeah, that's right. Okay. So let me try to so let me go to my whiteboard and then let's see. Like I will just I will explain it again once more. We will find max element and then multiply max value and then n, then subtract sum from that multiplication value. What is n? N is the number of balls. Okay, so you are finding the maximum element, multiplying it by n, and then subtracting the sum from that multiplication value. I did not completely understand if that is the solution. Okay, multiply with n minus 1, maximum value multiplied by n minus 1, and then subtract sum of all the elements, you're saying. Sum of all elements except max element. Okay, okay, I have to just see once the calculation. Would you, ma'am, could you send the link to the problem? I joined late. So I'm actually sharing this from the previous offering of the course, so I will not be able to share the link. I think you will not be having access to it. So I will just copy paste it in the chat box for all those who joined late. Okay, Shiv Kumar, we will discuss your solution. So let's first discuss the solution which was told by other people. And so let's go to the whiteboard. And yeah, the problem is very simple, so I will just quickly explain it. Let's see. Okay, this is from previous. Okay. Okay, so the idea is that when you put a ball in the magic box, it will always, the number on that will always get incremented. You cannot decrement it. So the only way you can make the number on all the balls same is by making it equivalent to the largest element. So whichever is the largest element in your set of numbers, you have to make the number on all the other balls equivalent to that. For example, in the second example here, the largest number is 1001. So you need to increment all the other balls by 1. So what you will do is that you will add all of these to the box once, and that is one operation. So the cost is only one operation because you are adding all the balls to the box once and taking it out. That is the cost here, which is 1. Now in case of the third test case, which is 12 and 10, here you have to do two operations because you have to put the ball 10 once in the magic box. When you take it out, it will become 11. Then you have to put it back again. Then it will become 12. So that is like, first it will be 11. You will get 11 and then it will become 12. So therefore two operations here. Now, so if I take some big test case here, let's say for example this. equal to okay. So this is here. So here the maximum element is 28, right? And we want to make all of them equal to 28. So let's first try to solve this like in a very ad hoc manner. I know that couple of you people have already told the answer, but let's try to do it in a very ad hoc manner. So first we will sort this. Let's say 1, then 5, then there is 10, 11. If I do it wrong, then let me know. 13, and then 11 again, and then 13, and after that there is 16, after that there is 19, then 24, 26, 26 and 28, right? I'm just cross checking that's right. Okay, so now we do not need to do anything with 28, and we will put all of these balls once in the back, and then when we will get to them back, we will have everything incremented by 1. So these will become 27, 27, 25 and so on. So now in the next time we just have to put them back again once more, then these two will become 28 and 28, and others afterwards in the third step we have to put only these many balls again. So what we are doing here is that we are putting a lot of balls together which are not yet equivalent to the largest number, and then once they become, if some of them are equivalent to the largest number, we don't put them again. So in this manner, if you will do it, you will understand that all you have to do is that the maximum number of times that you will have to put the balls in the box is equal to the difference between the minimum element and the largest element, because your goal is to make all the balls equal to largest element, and for the minimum element you have to put that many times, right? The difference, that is 28 minus 1, you have to put 127 times in the box to make it equal to 28. Okay, so that is the solution. Do you have any doubts in this explanation? Okay, I think.
Ma'am,
Yes.
I have a question that you have said that first we put the ball that have written 26 over it on in the incrementer, or we may say magic box. Can't we put all the balls at once and just eliminate after 26 is incremented to 28, some sort of that, because then it will reduce the cost, no?
Yeah, I think I said the same, but maybe it was not completely clear. So
Because you have put bracket, that's why I was confused.
okay, yeah. So I was saying that ball 1, 5, 10, 11, 11 up to 26, we will put all of them once in the first step. In the first step, we'll put all of these balls in the magic box. Then when we get them back, we will get 2, 6, 11, 12, 12 and 27, 27. So that will be the output after the first step. Then we will put all of these balls again in the box, and then we will get here 3, 7 and these 26 balls will become 28. Now in the third step, I've said that we don't need to put these two now. We will only put ball from whose original number was 1 to 24. That is the third step. And yeah, that is the trick how we are reducing the number of steps, which you pointed out correctly. Is it fine?
Yes, ma'am.
Okay, thank you. Okay, so now would you like to suggest how this can be implemented? I mean,
I think we have to use some sort of pop out command, which can delete the element in the array after it put a check over the element that it is equivalent to the maximum number in the previous array.
okay, okay, but Suyash, why is that needed? Because we just saw that if I want to make all the elements equal to 28, then that means I need to make at least make the smallest element equal to 28. So we at least need 27 steps, right? In this case, I mean, so in order to make 1 equal to 28, you need to put 1 in the magic box 27 times. So this observation tells us that and using the trick which you pointed out, that whenever we are putting balls, we are putting them in a collection. We are not just going to put only one, we are putting all the balls together whose number is not yet equivalent to the largest element, right? So that means the maximum number of steps required here is not maximum, I mean the minimum number of steps required here is the maximum element 28 minus the smallest element, which is 1. Is that clear?
Yes, ma'am.
Okay, so then, yeah, I think some people have added some comments suggesting how to implement this. So Sanaya told sort the array. Then Pushpinder told 2 variables to store min and maximum, order of n, array, 1 pass, max element minus min element, difference of max element minus min element. In Python, if L in the list, then print max L minus min L and max array minus min L. Yes, all of them are correct. Yeah, so yes, so like some of you suggested sort the array, which is absolutely right, and some of you suggested that just find the element, maximum element, and find the minimum element and take the difference, which is, and the time complexity will be order of n then, so which is also completely fine and in fact a better implementation in terms of time complexity. So let us now I would like to just show you, and I like to implement this. I think we can, I already have it, but I will just implement. So I am implementing here in C++. Okay. So first implementation which I have here is actually using the sort. So we can just see this first, and then we will see how to implement this in the better way, which is order of n time complexity. So let's see here. So first, the input format. The input format is that you need to first read the number of test cases. So let's define a variable t, then read the variable t. Then after that, we are given n, which is the number of balls, and then we have to read the number of the integers on these balls. Okay, so which we are doing here for every test case, which is the line number 9, while t minus minus, that shows that for every test case we are going to read the number of balls. Then we have created here a vector of integer. So vector is actually a container which is actually similar to array, and this vector is defined in, so this vector is part of the standard template library in C++. If you are not familiar with this syntax, then it is okay. You can write this code, rewrite this code in any language which you are familiar with, but all you need to understand that it will just create an array which you can then index, similar to you do in an array. Okay, so I have here created a vector of integers and named as vec, and then we will go over, or we will read n elements here. Okay, and then we are going to insert these elements in the vector. Then we are going to call the sort function, which is sort the elements in this range, which is vector.begin to vector.end, which is the
And
begin and
excuse me,
end. Yes.
can I get to know the time complexity of sort function that you are using, because I don't know.
Yeah, this is, I mean, I'm also not sure, but I believe that it is n log n. So this is a library function which is being used here, and I believe that it is n log n.
So it is as efficient as merge sort.
Yes, it
Okay.
should be at least as efficient as that. Otherwise, it's a library function. It could be even more efficient. I will have to, or one of you, like, if you are interested, you can go and check the documentation for sort function, that which algorithm is it implementing. Okay. So then we are sorting it, and if you are writing your own code, you write your merge, let's say merge sort, then definitely it will be n log n, right? So then you are sorting here in the ascending order, and after that your answer is that the last element of the array minus the first element of the array, and that is here, right? Now let's implement the other approach, which is order of n approach here. So I'll just copy this because this is same. Okay, so here now I can keep here two variables, let's say min and max. And I can initialize minimum to int max, which is the maximum integer in maximum value of the integer, and I will initialize max to the minimum value of the integer. Okay, then I do not need this vector also. I do not need to insert anything in the vector. I will just read the element. I will here just read the element, and I will put condition here. If the minimum value is if the element that I'm reading is less than minimum, then I will change the minimum to e. I'm sorry. Okay, and if e is greater than max, then I will change the max to e. Fine. And then outside the loop I will just do print cout max minus min. So let me remove the statements which are not needed. Let us compile and see. Why? What's it saying? Undefined reference to mean.
Ma'am, return value, return 0
Oh.
or then.
Thank you. Okay. Now let's give the input, which is I'll give only one test case, two elements, 12 and 10, and it's the answer is here. It's not, I hope it is visible. So do you have any questions in any of the implementations? Okay, good. Let's look at the next problem. Okay, so this is the next problem. You are given two integers and n and m. Consider a sequence A of length n consisting of positive integers such that a1 plus a2 plus dot dot an equal to m. Find the maximum possible value of the greatest common divisor of a1, a2, an. So I will give you a few moments to read the problem statement.
And please copy it also on chat box.
Sure, will do. And all of you, please call me Nikita. It's fine. Okay. Would you like to discuss the solution? Anybody has any ideas? I usually work in C++ and C. Which language do you write code in? In C. Okay, can you please show the test cases once? Sure. Yeah, I use C++ because then I can write the code, like I can use the standard template library, and then I will not need to write each and every function like sort. And for those of you who are like beginners in CP and also want to excel in it, I'll recommend that you learn C++. And you do not need to learn the object oriented part of CP. It's very similar to C, the basic syntax, and then you learn standard template library, and it will be very useful for you. Okay, so these are the sample test cases. So let's look at the sample example first, which is 3, 14. So n is equal to 3 and m is equal to 14. And so that means we have to find three integers a1, a2, a3 such that the sum of these integers is equal to 14, and these integers are chosen in such a way that we achieve the greatest common divisor which is possible. Okay, so here the output is that the solution is given as 2, 4 and 8, and the greatest common divisor is 2. So this is the maximum possible value of the GCD of any sequence of numbers which satisfy the given condition.
मैम मतलब मुझे पता तो है, लेकिन मैं सिर्फ 3 नंबर पे ला सकता हूँ. मैंने 8th क्लास में एलियोडिक डिवीजन लेमा पढ़ा था जो जीसीडी निकालने के काम में आता था, बट वो सिर्फ 3 नंबर के लिए पॉसिबल है. बस से ज्यादा हुए तो फिर काम नहीं करेगा.
Euclidean, you are saying?
हाँ, यूक्लिडियन डिवीजन लेमा.
Okay. M%n. Yeah, Vinayak, I don't think that is the answer. Okay. Okay, no problem. So let us try to understand this. So we have to find these n elements, okay, such that each element is divisible by some element, say d, and that is the greatest common divisor which is possible. Okay, so let me use the board. Here let us say that the GCD of a1 a2 dot dot an is d. Okay, it's visible. Okay, then we can say that every element is divisible by d, right? So every element is divisible by d. So that tells us that a1 plus a2 plus a3 plus dot dot plus an, will it be visible by d? Since every element is divisible by d, therefore the sum of these elements is also divisible by d. So, and what is the sum of these elements? That is nothing but m, because we are told that we have to choose these elements such that the sum is equal to m. So that means m is divisible by d. And what is d here? D is the GCD of these elements that we are trying to find. So the first observation that we have made here is that the answer, which is d, must divide m. Okay, it must be a divisor of m. So let's see. Now what is the, now let's see, when d is divisor of m, then what can we say? We can say that all the elements, we know that d is the divisor of m, and d is also a divisor of all the elements, that is all the elements a1 a2 a3 dot dot an are greater than equal to d. So that implies that m must be greater than equal to n multiplied by d, because each element is at least d. It must be greater than d, right? And there are n elements. So that gives us this condition that m must be greater than equal to n times d. Now if this is clear, now you may ask that how can we assign how can we choose these numbers a1 to an? Now what you can do is that one of the possible sequences which satisfy the condition could be that we can choose a1 equal to a2 equal to dot dot equal to an minus 1 equal to d. We can assign d to all the elements except the last element, and then the last element an will be m minus n minus 1 times d. There is a multiplier here. Okay, so now we have found that D is a divisor of M. So now we have reduced our domain of the possible answers to the divisor of M, right? Now in those divisors, we have to find the largest divisor which satisfy this condition, because we want to find the maximum possible GCD. So we need to find the largest divisor of M which satisfy this condition, M greater than equal to N times D. Let me know if it is not clear.
मैम वो सेकंड स्टेप में आपने उसके बाद जो बताया ना, मतलब वो एक बार फिर से बताइए प्लीज।
Second step में ये वाला you mean?
हाँ ये वाला।
Okay. I'm saying that now if you want to also find the sequence, means the values of these elements a1, a2, an, then one of the possible sequences can be a1 to an minus 1. Give assign the divisor D value to all these n minus 1 elements, and for the last element you can compute it like this, because we know that the sum of the elements is m, so m minus the sum of all the rest elements a1 to an minus 1, which we have assigned as D, so n minus 1 times D.
Okay, this is one assumption of sequence.
Yeah, this is one of the possible sequences I'm saying. So we know that a1 plus a2 plus dot dot an is equal to m. This is the condition that we have to satisfy. This is given in the question. Now I'm saying that if I have given value D to all of these n minus 1 elements, then what is the value of this element? That we can find out. And that is one of the possible sequences which will satisfy the condition, that is the sum of the elements is equal to m, and the GCD of all the elements is D. Now why is the GCD D? Because m is divisible by D, n minus 1 is divisible by D, so the GCD of an is D, and all of the other elements are D itself, so therefore the GCD is D. Any other questions? Okay, so there are no questions. Let us look at the implementation for this. So I've already implemented it here. So the first
Ma'am,
Yes.
you are saying this from en equal to gn, where the maximum possible case arises for GCD is because you have taken very specific sequence. You have not taken any random sequence. So it is because of some AMGM inequality or some other thing.
sorry, I did not understand.
I wanted to say, you are saying by taking such sequence, I can ensure a maximum value of GCD, right?
Right.
So this is deriving from equality of arithmetic mean equal to geometric mean, or some other thing it is, something else it is.
Okay. So so that is I'm not saying that this is the only possible sequence. There could be other sequences which will satisfy the condition and also have the GCD equal to D. For example, here in the example itself we can see, like for the first example, they have given that one of the possible sequences 2, 4, 8 as the answer, and the GCD is 2. But what I'm saying is that if the GCD is 2, then I can assign 2, 2 and 10. So that is also one of the possible sequences, such that the GCD of all the elements is 2, and which is the maximum possible GCD.
Okay, understood.
Okay, great. So I will also explain the answer again with the implementation. So what we said was that we want to find the greatest common divisor of all the elements a1 to an, such that the sum of the elements is equal to m. And then the first observation that we made was that m is also divisible by the divisor d, which is our required answer. So we are looking for this GCD, and if the GCD of all the elements a1 to an is d, that means it divides a1 to all the elements a1 to an, then that d value must also divide m, right? So then we have reduced the space of our possible solutions to all the divisors of m. So the first function here is get divisors of m. So we are going to find all the divisors of m, and I have written here a very simple code, which is that I am going to iterate from integer 1 to m, and I am going to check if the integer I divides m, then I am putting it in the array of divisors, and then I am returning this array of divisors, or the vector of divisors, right? And then in the second observation, we saw that this divisor d, we want to find the greatest divisor of m which satisfies this condition. So that is all which I have written here, that once I have got all the divisors, then I will traverse through all the divisors from 0 to the list of divisors, and I am going to see those and if I find any divisor which satisfies this condition, then I am going to change the answer to that. So initially the answer is 1, because you will always be able to say that the greatest common divisor is 1, like that is always the case, right? And whenever you find anything any better, you will update it, and then finally I am just printing the final answer. Now this is not the most efficient code, definitely. There are a couple of places where you can optimize it. Now first I would like to know if the code is clear or not, and second I would like to know what are the ways to optimize this code. Yeah, right. In get divisors we can optimize it. Now, first, does anybody have any question? Did you understand it or not? If you did not understand it, then please feel free to unmute yourself, ask me questions. Okay, someone had asked that explain with example. Explain again. Priority queue instead of vector. Okay, first I will ask Swapnil and Sangu Sandeep, that is it clear, or should I explain it again with an example? If it is not clear, then I can explain it again with an example. Clear? Okay, good. Clear. Okay, thanks. Okay, so for those of you who are finding the course extremely difficult, So the first thing is that for this course, the prerequisite is that you need to know at least one programming language, say C, C++, Java, Python. And other thing is that you also need to know the data structures and algorithms. If you do not have any experience with these topics, then the course can be challenging for you. It can be more challenging for you than it was planned to be. Okay, I will explain again with example. Okay, yeah, Kunal, I think you are suggesting some better approach. Yeah, we can run a loop over 1 to m, and then we can, instead of then the first condition will be to check whether it is a divisor of m or not, and then we can check whether it is satisfy the condition or not, and then we can update the value of d, yeah, whenever we find a better approach. Yeah, that will also be a good way. So this question, you're asking me to take an example and then explain. Okay, I will look at the comments. Okay, so we are given two values here of n and m. N, like I'll take the first sample example, which is n is 3 and m is 14. So the question is saying that find three such elements such that the sum is equal to m. So a1, a2 and a3 such that the sum, which is m, is equal to 40. So what are the ways? I can assign 1 to a1, a2, and then I can assign 12 to a3. But the GCD in this case is equal to 1, right? And then after that, we can find other, let's say I assign a1 to 2, then I assign here 3, then I get 5 and there 9. Now here again the GCD is 1. Now we can, so a lot of I don't know, I won't count it, but many sequences are possible which will satisfy the condition, and we have to find one such actually the question is not about finding one such sequence, but the question is about finding the GCD, maximum possible GCD of these elements a1 to an, such that the condition is satisfied. So what we said was that here that GCD is the number which will divide all these elements a1 to an. So let us assume that number is d, okay, and then if this number is dividing every element a1 to an, then it will also divide the sum of these elements, which is m. Okay, so with that observation, we found that the answer D must divide m. So that means we need to find the answer must be one of the divisors of m. So the divisors of m here are 1, 2 and 7. And the GCD is going to be one of these elements. Okay, then the second observation which we made here was that okay, sorry, here. So the second observation we made here was that when this D is divisor of M, and if and we know that all the elements A1 to AN will be greater than equal to D, then M will be greater than equal to N times D, at least. I mean, this is the condition, because if we assign D to every element A1 to AN, then the sum of these elements will be at least N times D. So M must be greater than equal to N times D, and that's the condition. So then we will go one by one on this list of elements here, which is the divisors, sorry, here, and we will try to find the largest possible divisor which satisfy this condition. So we'll go for, let's say, 1. So M is 14 greater than equal to N is here 3 times 1, condition satisfied. 14 greater than equal to 3 times 2, condition satisfied. 14 greater than equal to 3 times 7, not satisfied. So that means our answer is 2 in this case. So I had asked you that how will you, I hope this was clear. If not, then please let me know. And yeah, I had asked you how will you optimize the code, and couple of you gave the answers. So yes, the first possible way, first of all, many of you correctly observed that the get divisor implementation here is not optimized. So you only need to traverse this for loop till the square root of M, and then you can push like you can insert the divisors in this array as M divided by I and I itself, if M percent I is equal to 0, condition is satisfied. Okay, so that will be the first change, that is optimizing this, because currently it is order of N time complexity, and doing that will reduce it to order of square root of M. Then the second one here is this is not going to make I think it is not going to optimize very much here in terms of time complexity, but you can write this for loop from in the descending order, from the greatest to the smallest divisor, and then whenever you find the first divisor which satisfies this condition, you can break the loop, and that the time complexity still remains order of N, but unnecessarily you will not have to traverse all the elements unless the one is the GCD. Okay, let's see if there were other. If we are doing this it would be more efficient to run the loop from M by N to 1 and break if we find a D that satisfies M by N to 1. Yeah, it could be. Yes. So okay, all of you have suggested some really good optimization strategies, so I will ask you to code it now that you have I will also, so this recording will be made available, it will be posted on YouTube, and I will also post the problems on Discord. And if you have any more questions related to this session, then please post your questions in week 0 Discord channel, and do try to code these problems whichever we discussed today in any language that you prefer. And if you are facing any problem, then please post it on the Discord channel. And yeah, you have suggested some optimizations, and I would like that this could be your homework, that you go and write the code for the optimized implementations. So if you have any questions, then please ask me. Otherwise, we can meet next Friday 6 p.m.
Hi, am I audible?
Yes.
Yeah, this is not regarding the problems that we discussed today, but I noticed you said that we use C++ or C for competitive programming. I'm new to competitive programming. I just wanted to know why C++ in particular.
Yeah, so I prefer C++ because of like because I can use then standard template library. If I have to write some code in C, let's say I want to use heaps, then I will have to implement heap from scratch. If I want to use sort, then I will have to implement some sorting algorithms, say merge sort, quick sort myself. But if I am working in C++, I can use the STL library, standard template library, which has a lot of which provides so many options. You will find there all these algorithms like sort, and there are so many container options for like vectors, set, maps, heaps, priority queues, and so it becomes easier.
Okay, so let's say, do we have to follow the same thing if we are also, I mean, if I'm preparing for a coding interview, so would you also suggest C++ for that? Like a coding interview.
I think if you are expected in the coding interview to write the code in from like completely, if they're expecting you to write only the pseudocode, like you do not need to implement, let's say you say to them that I will use sorting, and you just assume that you are given a sorting function. You can assume that there is a library, you will give the array to it and it will sort and give it back to you. Then okay, you don't need to then learn C++ and the STL library. But if you are expected to write a code that they can just run and it will run, then I will definitely recommend that you learn STL.
Okay, yeah, right. Thank you.
Yeah, no problem. Yeah, anybody, if you have any questions, if you're new to CP and if you want some guidance, then please let me know. I hope that I can help.
Hello, ma'am.
Yes.
This is Praneeth.
Yes. Hi, Praneeth.
Ma'am, I have proficient skills in C++, but I'm finding it difficult to solve the problems in hacker rank or what.
Sure.
As next 2 months are going to be in our college internship months. So, what suggestions you would like to give to me to
Okay.
improve my practice skills?
Yes, I'll just stop